Hello. Hello.
Yes, sir.
हाँ एक्चुअली मुझे आज याद नहीं था कि एक्स्ट्रा लेक्चर है एंड also from your CR I didn't get any confirmation, so I forget to schedule. Okay, so right now just I confirmed with her and then I scheduled the meeting. Okay, so sorry
So
for
you can
that.
postpone if you want.
Sorry.
So you can postpone if you can't take it.
No, it is okay. If you are ready, then I have no problem. You all are okay, na?
No, sir.
We are all tired, that's why.
No, sir.
We have
So
we
मुझे आया
just
था
had
फिर
practicals.
ओके अभी हमने शेड्यूल कर दिया है और हम मीटिंग में आ भी गए हैं, तो अभी लेट अस कंटिन्यू फॉर 1 hour. ओके, at least 40 minutes at least. Okay, then we'll try to evaluate. Okay, is it okay? Hello.
Okay, sir. Till 4:10 then.
Okay, sir.
At least we'll solve one numerical and then I will try to zero. Okay, ठीक है?
Yes, sir.
Yes, sir.
Basic concepts and one numerical I will cover and then I will review. Okay, I will not extend beyond what I say. I have 40-50 minutes. Okay, will it be okay?
Hello, sir.
हाँ सर अभी तो चालू करो.
हाँ तो अभी वही मैं बोल रहा हूँ, सब आ गए क्या? अभी आना तो चाहिए ना सबको.
आ रहे
3:30 हो गया. ओके 3:30 हो गया ना, ठीक है, then we can start. Okay, so good afternoon. I hope you can see the screen. Okay, screen दिख रहा है सबको?
Good afternoon, sir.
Yes, sir.
Sir, can you give 10-15 minutes break?
No, I am leaving you early ना, तो 10-15 minutes कैसे break दे
सर
सकता हूँ?
हम लोग ने लंच भी नहीं किया, अभी जस्ट लेक्चर खत्म हुआ.
Yeah, sir, that's why we said.
तो
सर हमें लंच करने दो.
अभी मुझे सीआर से फीडबैक ऐसा मिला कि शेड्यूल करो, ऑल आर फ्री. मैंने पूछा अभी उनको, कृषा है, कृषा इज देयर?
उनका सीआर सर. अरे सर सीआर को क्या पता है.
सर क्रिशा खुद हम लोग के साथ
Yeah,
लेक्चर
sir.
में थी.
They have different practicals, na? So सबका अलग-अलग खत्म होता है accordingly. Half of us was still in the practical.
बोल रहा हूँ.
So what you want now? You want 10 minutes break?
कैंसल.
Or you want?
3:50 से
Or if you can
4:30
schedule
तक.
कर लो,
Yes, sir.
that is also fine.
4 बजे शुरू करो.
नहीं अभी तो आप इसमें ही 10 मिनट दे दो, ठीक है? अभी मीटिंग में वापस शेड्यूल नहीं कर सकता, ठीक है?
सर कल
Otherwise it will be
10:20 से
very.
10:20 टाइम है. मैकेनिक्स
Sorry?
का ही आप में ले लो.
किसका?
कल
हाँ
सुबह 10:30 ले लो सर.
नहीं, tomorrow it will be taken by मीता मैडम, so वो उनका शेड्यूल है and I will be busy with some other work ना, so not an issue if you want to take a break or that's also okay. या फिर आपको जल्दी छोड़ना है तो I am agree with you. Just tell me.
हाँ सर, जल्दी छोड़ दो.
सर जल्दी मतलब कितना बजे तक?
जल्दी छोड़
20
दो सर.
मिनट में.
Yeah, sir.
ठीक है, कितना जल्दी छोड़ू आप बोलो.
4 बजे.
4,
अभी
5.
5 मिनट.
अभी तो 4 बजने ही आ गया. ठीक है, चलो ठीक है, 4:10 तक करेंगे.
हो जाएगा.
ओके,
4:10
तक करेंगे. ओके,
Yeah, sir. Thank you, sir.
आज का
Yes.
टॉपिक क्या है?
Thank you, sir.
all are fine, all are fine,
हो जाएगा.
Yes, yes.
all are fine with
Yes,
that.
yes.
Yes sir, yes sir.
Yeah, sir.
Yeah, okay, so now don't waste time. Okay, let me start now. Thank you.
Let's start. Yeah.
So I hope you can see the screen now. Today's topic is we have covered kinematics of particle. Now here we are going to study the kinematics of rigid body. So a rigid body, you know that, okay, is nothing but ये idealizations मैंने already बताया हुआ है आपको. When we treat a motion as considering rigid body, when we treat motion considering a particle. Okay, so I will go a little fast. Okay, here A rigid body, you can see it is a special case of system of particles wherein the distances between all the particles remain unchanged. Okay, and you know that in two-dimensional plane, if we keep that a rigid body, it has only three possible motions. Namely, what? Two translational motion it can have, one in x direction, one in y direction, and one rotary motion. That means it can have only 3 degrees of freedom. Okay. Now, with with reference to the degree of freedom, we can define certain motions. Okay, what are those types of motions which are possible? That are translational motion. Okay, first thing, that is a translational motion. We already know translational motion क्या है, हमें बताया हुआ है. Translational motion is a body when it is we can say body is performing translation only if the line of body remains parallel to itself throughout the motion. That means the displacement or velocity along the line parallel to the path is always same for all the particles. Okay. Similarly, we can have a rotational motion. Rotation means what? Rotation, if we talk about, then that time we can say that body is rotating about certain fixed point. Okay, so it will always rotate with reference to some fixed point, and it will be what giving us the some circular kind of path, right? Huh? So a rigid body is rotating about a fixed axis if and only if the line of body remains fixed throughout the motion. Okay, are you getting? And all the particles of the body have zero relative or angular velocity with respect to the some reference. Okay. In this case, see, a rigid body rotating about a fixed axis will have only 1 degree of freedom. Okay. Now, one can understand the pure rotation, one can understand the pure translation. But what if the body is not performing a pure rotation as well as pure translation? Then in that case, we can say that motion is a जनरल प्लेन मोशन. Are you getting me? मैंने फर्स्ट लेक्चर में एक मोशन डिफाइन किया था, जनरल प्लेन मोशन. जनरल प्लेन मोशन वो होता है, okay? General plane motion is that motion in which body will neither be in pure translation, neither or nor it will be in pure rotations. I hope you are getting it. For example, if I tell you, let's say for example, अगर मेरे पास एक मैं आपको एग्जांपल दिखाता हूँ. Just let me show you the example. Just a moment. See, this you can see. This is screen you can see. Hello. Hello.
Yes, sir.
दिख रहा है
So here in this you can see this is what translational motion. Okay, this is rectilinear translation. Here you can see this is curvilinear translation. Then here you can see this body is what rotating about a fixed point. That is a this is the A1 B1 C. You can see this is axis of rotation of the body, and body is rotating about C. Okay. Now the section number B you can see here the general plane motion which I have highlighted here. You can see इसमें क्या हो रहा है. इसमें आप जो भी एग्जांपल देख रहे हो, देखो यहाँ पे अभी यहाँ पे 2-3 एग्जांपल दिखाया हुआ है. फॉर एग्जांपल इफ यू से नीचे वाला एग्जांपल देखो, सबसे सिंपल एग्जांपल, मोशन ऑफ बार AB फ्रॉम A1 B1 टू A2 B2. अभी ये बार AB में क्या हो रहा है? सी, the bar AB is resting against the wall. Okay, so what happened? What happened if suppose it is sliding? Okay, let's say now it is coming to the new positions. Yeah, initial positions was B1, B1. Hold on. Hello, am I audible? Hello, audible? आवाज आ रहा है? हाँ. So in this case, what happens is, see, अगर यहाँ पे आप देखो ध्यान से तो body initially was kept like this A1 B1, okay, initial condition, and after some time body what attains the position A2 B2. Now this position A2 B2 can be split into two components. One, because see here what happens is this bar AB when it performs the motions, okay, so it is neither under pure translations nor it is under pure rotations. So in that case, what we can see here, if you can see, B point is what B1. If you see B1 point is being shifted here to new position, that is B1 dash. Okay, and A1 point is being shifted at A2. Correct? Right now, here you can see this is what the translation, and then at the same time this अगर ये यहाँ से position B1 पे आया and A2 then again it is lifted, okay, again it is lifted at new position, that is B1 dash and A2. Now it is being what rotated in the anti-clockwise directions so that it will come to B2. I hope you are getting me. Hello. Now once it is coming to B2, so this A2 will what A1 will not remain A1. A1 will come at A2. That is rotation about end A. That simply means I want to tell you that this rod is simultaneously performing the translation as well as the rotations. Okay. If I will take another example, let's say उससे भी simple example मैं देता हूँ. Let's say motion of rolling cylinder on horizontal surface without slipping. Or you can simply say the example of the vehicle का जो उसका wheel होता है, ठीक है, and that vehicle का wheel is what rolling about a surface, ना? Are you agree with that? Now when it rolls on a surface, क्या होता है? आपको लगता है अगर सिर्फ वो रोटेट होगा तो गाड़ी आगे जा पाएगा? गाड़ी आगे सिर्फ रोटेशन की वजह से नहीं जाता. So simultaneously that wheel is performing what? The translational motion as well as the rotation about a fixed point. Means वो wheels क्या होते हैं? It is rotating about certain fixed point, okay, and at the same time it is moving also. It is translating also. So in the diagram you can see the initial plane motion is shown here.
Page is not visible. Can you just zoom a little bit? It's
Okay.
but not like readable types.
नहीं रीड करने का जरूरत नहीं है. फिगर दिख रहा है ना आपको? फिगर दिखा?
हाँ हाँ सर.
रीड करने का जरूरत नहीं है. रीड करने के लिए बाद में आपको कंटेंट ये चाहिए तो मैं आपको सेंड कर दूंगा, ठीक है, आप रीड कर लेना. आई एम एक्सप्लेनिंग द सेम थिंग, तो यू कैन रीड आफ्टरवर्ड. ओके, यू कैन जस्ट सी द एग्जांपल दिख रहा है ना आपको? बस इतना ही मुझे कंफर्म करो.
ओके सर.
नाउ यू कैन सी. इज इट ओके?
यस.
हाँ, तो नाउ यू कैन सी हियर क्या होगा पहले. अभी देखो ये आएगा A1 से यहाँ पे देखो. दिस मोशन ऑफ A1 B1, ओके, is split into two components, translation plus rotation about the center. Okay, तो ये जो यहाँ पे directly दिखाया हुआ है देखो, plane motion of this wheel is what the combined plane motion is shown in this A2 B2. Okay, लेकिन ये A2 B2 आया कैसे, वो right hand side में दिखाया हुआ है. This is shown in the right hand side by splitting the motion into its translation and rotation. So always when we talk about the general plane motion or what you can say plane motions, so always remember it will be nothing but combining motion. Okay, it will be a combined motion, that is it will include translation as well as rotation about this point. So as in this example on the right hand side you will see this wheel is this wheel is initially in the beginning it will translate, and once it will translate, translation is what? Translation is along a parallel path. In translation, each of the particle follows a parallel path. So A1 will come to A2. Can you see this? New center आपको दिख रहा है, नया center A2. And at the same time, B1 will come to B1 dash. Are you agree with this? They will be parallel to each other because in translation, what? The path followed by the particle is parallel. Correct? Huh? Hello? When you trace the path of the particle, you will find that it is a straight parallel line. Is it correct? तो ये जो हो गया हाफ पार्ट हो गया प्लेन मोशन का, दैट इज ट्रांसलेशन। पहले बॉडी ने क्या किया, ट्रांसलेट किया, ये आ गया कहाँ पे, A to B1 dash पे आ गया, न्यू पोजीशन। Now at the same time what will happen, it will rotate about some point, fixed point, that is what A2 here. So A2, can you see here, this is A2. Now it will what, rotate about this A2, okay, in the opposite direction, then it will come to new position, that is B2. So B1 dash से कहाँ पे आ जाएगा वो, that it will arrive at B2. B2, can you see that? The final position we get is A2 B2, that was same here. Okay, so A2 B2 जो है is can be split into these two, translation as well as rotation. Are you getting me? Is this understood? Any doubt up to here? Hello. Because first criteria here is to identify the motion. Okay. Once you identify the motion, then only you can analyze this. Okay. तो जनरल प्लेन मोशन कहाँ पे, क्योंकि आपको जब प्रॉब्लम दिया रहेगा तो उसमें से कौन सा लिंक, कौन सा पार्ट जनरल प्लेन मोशन परफॉर्म कर रहा है, दैट यू नीड टू आइडेंटिफाई, एंड देन वंस यू आइडेंटिफाइड, देन अकॉर्डिंगली उसका एनालिसिस आपको करना होगा उसके रूल्स और मेथोडोलॉजी के हिसाब से। इज इट ओके? इज इट अंडरस्टूड? Shall I explain again? Hello? 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 Hello?
Yes, sir.
Can anyone respond? Is it understood?
Yes, sir. Yes, sir.
सबको समझ में आया? हाँ, तो जनरल प्लेन मोशन आपका एक बेसिक आइडिया आ गया ना कि क्या है एक्चुअली, इट इज व्हाट इट इज अबाउट। नाउ लेट्स सी। हेलो, आर यू सेइंग समथिंग?
No.
Yeah. Now see, when the body is performing a general plane motion, okay, so since it is neither a pure translation nor it is a pure rotations, okay, so what we do in this case, okay, because we cannot analyze such a mechanism which is performing both simultaneously, translation as well as rotation. So in such cases what we do, we consider the motion of the body as pure rotation about a certain imaginary point, okay, about, and that point call it as a instantaneous center point, okay, instantaneous center point, ठीक है। तो combined motion of the rotation and translation may be assumed to be a motion of the pure rotations about some imaginary point, that is instantaneous center point. तो ये जो आपका अभी मैंने एग्जांपल दिखाया था, जो आप यहाँ पे as in this case you can see this translation plus rotation, ठीक है, जो कॉम्बिनेशन है इसको आप प्योर रोटेशंस कंसिडर करके सॉल्व कर सकते हो। लेकिन कैसे, क्वेश्चन आता है कैसे, तो उसके लिए क्या करना पड़ेगा, एक इमेजिनरी पॉइंट, उसके लिए हमको एक इमेजिनरी सेंटर, मतलब हम बोल सकते हैं कि उस पॉइंट के अबाउट दिस बॉडी इज परफॉर्मिंग अ रोटेशन, एंड दैट पॉइंट विल बी वेरिंग इंस्टेंट टू इंस्टेंट। मतलब अगर बॉडी सपोज एट t1 इज इक्वल टू 5 सेकेंड्स पे कुछ अलग मोशंस, सपोज 5 सेकेंड्स पे कुछ अलग लोकेशंस है, तो उसका जो मींस लेट्स से आई मीन टू से हियर इज फॉर एग्जांपल, जस्ट अ मोमेंट, I hope you can see the screen. So let's say at स्क्रीन दिख रहा है बराबर? अभी ये जो रॉड है, रॉड का जो मैंने बताया आपको, ठीक है, ठीक है, दिस रॉड, okay, this rod you can see ना, and you know that this rod is what, performing a general plane motions, correct? This is performing a general plane motion, correct? Means इसका motion जो है that can be split into what, its translation motion and rotation motions, correct ना? तो ट्रांसलेशन में अभी यहाँ पे आपको डायग्राम में दिखाया हुआ था, यहाँ से let it be ट्रांसलेशंस का कंडीशंस क्या है कि इट विल फॉलो द पैरेलल पाथ। तो ये मोशन जो है ट्रांसलेशन प्लस रोटेशंस, ओके, दोनों में स्प्लिट हो सकता है। तो इसको हम बोलेंगे कि ये प्योर ट्रांसलेशन भी नहीं है, प्योर रोटेशन भी नहीं है। तो इसका एनालिसिस बहुत डिफिकल्ट हो जाता है, समझ में आया। और अभी इसको सिंप्लीफाई करने के लिए फॉर दिस so in such case what we can do here is, instead of considering this translation plus rotation, okay, are you getting me? I hope मैं ज्यादा फिगर वगैरह नहीं दिखा रहा हूँ आज, क्योंकि आपने मुझे टाइम लिमिटेशंस दिया हुआ है, ठीक है, और उस टाइम लिमिटेशंस के हिसाब से मैं आपके सामने वो कंटेंट रख रहा हूँ, ठीक है। तो आई एम नॉट गोइंग इनटू little more discussion and depth. I am just explaining you the concept, and accordingly जितना उसके हिसाब से relevant है I will explain, okay. So due to this time limitations, I am representing that examples and trying to illustrate you, okay, the prerequisites which is required for that chapter, okay. I hope you are getting me. Hello. Hello.
Yes, yes.
आवाज नहीं आ रहा है क्या? हेलो।
हेलो।
आ रहा है ना आवाज?
Yes, sir. Yes, sir. Loud and clear.
So what I am saying here is, you can note it down if you want. The combined motion, this combined motion of rotation, motion of rotation and translation, okay, may be assumed to be a, this statement is a very important, be assumed to be a motion of pure rotation about एक second, pure rotation about some imaginary center, about some imaginary center, okay, which is known as the instantaneous center. Okay, and the position of this instantaneous center, position of instantaneous center keeps on changing. Okay, why this keeps on changing? Can anyone tell me? इतना तो क्लियर हो गया सबको, आई होप कि दिस इज व्हाट, ये जो लिखा है यहाँ पे इसका मतलब क्या है, ओके, एंड दिस इज नॉट ऑफ व्हाट actual definition of instantaneous center. This is what how we analyze this general plane motion, okay, considering as a pure rotations. This, as per this assumption, this is the definition. तो ये इंस्टेड ऑफ दिस ट्रांसलेशन और रोटेशन दो कंसिडर करने से अच्छा हम इस कंबाइंड मोशन को पूरा एक रोटेशन एज्यूम कर लेते हैं, ठीक है, एक पूरा रोटेशन एज्यूम कर, लेकिन ये रोटेशन अपने एक्चुअल जो रोटेशन होते हैं उससे अलग है, एंड यू नो दैट रोटेशन इज अबाउट सर्टेन सेंटर। तो वो सेंटर जो है हमको एक इमेजिनरी सेंटर देना पड़ेगा, एंड दैट वी कॉल दिस एज अ इंस्टेंटेनियस सेंटर, ओके। तो ये इंस्टेंटेनियस सेंटर का पोजीशन जो है चेंज होते रहता है, बिकॉज दी व्हाट इंस्टेंट टू इंस्टेंट क्या होता है इसका नाम, इसलिए दैट्स व्हाई इट इज नेम्ड एज अ इंस्टेंटेनियस, बिकॉज इंस्टेंट टू इंस्टेंट व्हाट हैपेंस, इंस्टेंट टू इंस्टेंट the rings ka positions will be oriented in a different manner. That's why as per this orientation, this instantaneous center will be accordingly shifted. Okay, तो वो accordingly अपने आप shift होता जाएगा. Okay, जैसे अभी let's say for example इस केस में अगर मैं यहाँ पे इसका instantaneous center कहीं पे बोलता हूँ यहाँ पे है अभी for let's say example t1 is equal to 5 seconds पे. So suppose now I want try to change these orientations, okay, and I just kept it little bit in this little bit ऐसा कुछ और थोड़ा सा position change किया, okay, या इसका मैंने dimensions change किया, ठीक है, तो it will affect the motions. So t2 is equal to 10 seconds पे इसका ये instant पे ये positions change हो सकता है. That's why it is what instantaneous center. Automatically that center will be what shifted accordingly. Okay, and that's why it is not a fixed center, it is an instantaneous center. इसलिए इसको हमने क्या बोला है, imaginary. तो ये imaginary center है, वो जिस इंस्टेंट पे हमको वो मैकेनिज्म्स यानी जिस इंस्टेंट पे वो हमको बॉडी का फाइंड आउट करना है पैरामीटर्स, वो इंस्टेंट पे हमको प्योर रोटेशंस कंसीडर करके उस इंस्टेंटेनियस सेंटर से हम उसको डिटरमाइन कर सकते हैं. दैट इज व्हाट एक्चुअली the meaning of instantaneous center. Now let us see the actual definition. So here, if I have to define this instantaneous center, so how I will define the instantaneous center, okay, is a point of zero velocity, and it is defined as a point about which all the particles of a rigid body have same angular velocity about the instantaneous center. That means, see, if I have some mechanisms, okay, अगर कोई भी mechanism है और उसको इस तरह से connected किया हुआ है कि उसका जो angular velocity है, we all know that what is angular velocity. Okay, see that we all know that this what angular velocity is given by v upon r, correct? So omega is what function of this v and r. So if this r will be changed, this omega will be changed, correct? But here this is a point, instantaneous center is such that where इस पॉइंट पे अगर हमने इंस्टेंटेनियस सेंटर पे कोई भी अगर लिंक कंसीडर किया, लेट्स से अभी इसमें जो है और एक है मैकेनिज्म्स, ओके, लेट्स से यहाँ पे मैंने कुछ ऐसा मैकेनिज्म कंसीडर किया, स्लाइडर क्रैंक मैकेनिज्म्स, ओके, ऐसे कुछ ये क्रैंक जो है रोटेट हो रहा है, लेट्स से, एंड दिस इज व्हाट स्लाइडर एंड दिस इज अ लिंक, ओके, दिस इज रोटेटिंग विद ओमेगा. तो आई कैन लोकेट इट्स आईसीआर. अभी वो आईसीआर कैसे लोकेट करना है उसका मेथड है प्रॉपर, ओके, वो अभी इसके बाद में जस्ट आई विल टेल यू. So if suppose if it is sliding, okay, in this it is rotating and it is sliding in this directions, okay, so this ICR or instantaneous center will be a point about which we can consider all the rings will have the same angular velocity, okay. तो इसकी वजह से हमको क्या हो जाता है, we can easily calculate the velocities of that particular ring, because omega अगर हमको ICR हमको पता चल गया, instantaneous center उस point का पता, उस ring का पता चल गया, तो we can just join that and that point to of which we have to find the velocity. वो point को join करने से हमको उसका distance मिल जाएगा r, and then we can easily apply this relation, that is v is equal to r omega, and we can find out the relative velocity, correct? Are you getting me? ऐसा नहीं है कि only one method is there to analyze this kind of motions, general plane motions. To analyze the general plane motion, we have alternative options also, that is relative velocity method. But this method is faster and this method is more accurate. Accurate in the sense it gives correct result in a much short span of time. Okay, are you getting me? Hello. So at a given instance of time, the angular velocity of all the particles about that point is constant, we can see. Okay. Now I will show you the different cases in which we will see how to mark the इंस्टेंट सो अभी इतना तो आपको क्लियर हुआ कि व्हाट इज इंस्टेंटेनियस सेंटर. ओके नाउ अब क्वेश्चन ये है कि इंस्टेंटेनियस सेंटर फाइंड आउट कैसे करना है. ठीक है, बिकॉज अगर इंस्टेंटेनियस सेंटर जब तक हम लोकेट नहीं कर पाएंगे तो हम उसको एनालाइज कर नहीं पाएंगे. ठीक है ना, प्रॉब्लम्स. तो फॉर दैट लेट मी शो यू द this some screen. Can you see this? First let me show you this. Okay, here let me first differentiate this. So here you can see this pure rotation about point A. This is in the first diagram. You can see this link is performing a pure rotations, correct na, about point A, that is hinged point A, and with certain angular velocity, that is omega AB, correct. And its velocity is what given by VB, that is perpendicular to the link, correct. Velocity will be always perpendicular to the direction of the link. This you have to remember. Okay, suppose if suppose it is your link. Okay, this is your link and this omega is what in this direction. Okay, so let's say this is A B. A B is your link. Link is nothing but element of the or part of the machine components. Okay, so this is, let's say, AB. Okay, relative velocity of link AB. Now depending on the direction of this AB, okay, how this, since this is what rotating about this point, let's say, okay, this is a pure rotations, correct. This is a pure rotations. What will be the direction of velocity? Well, velocity का direction हमेशा याद रखो. This will be always perpendicular to the direction of the link. तो ये ऐसे कहीं तो होगा, perpendicular होगा. But what will be the direction of arrow? Will it be in this direction or will it be in this direction? So for that we need to see this omega AB का direction. Omega AB is what trying to what rotate it in the clockwise direction. So that's why this V will be in this directions. Are you getting me? On the other hand, if I suppose consider like this is A, this is B, but suppose ये ऐसा दिया होता था, तो VB would have been like this. Is it okay to you? Hello? This is what first thing you need to keep in mind. Okay, that is what the direction of the velocity, how to mark it. Okay, are you getting me? Hello?
Yes, sir.
Yes, sir.
हाँ, तो now next is to find out or to locate the instantaneous center. Okay, तो instantaneous center अलग अलग केसेस में अभी हम देख लेते हैं कैसे मार्क करना होता है. ठीक है, क्योंकि जब तक हमें instantaneous center नहीं मिलेगा, ठीक है, तो हम उसके बिना कुछ कर नहीं सकते. And that's why this method is called as the instantaneous center of rotation method. In short, it is called the ICR method. So this particular chapter is named as kinematics of rigid body, and in this particular chapter we are going to see how to analyze a rigid body, okay, which is performing a planar motion, okay, general planar motions, okay. Now since it is a rigid body analysis, kinematics of rigid body analysis, so we are going to consider here the shape and size of the body as well, because it will affect the motion parameters, right? So this is what the chapter name, and the method which we are going to adopt is, that is ICR method. Okay, is it clear to you? Now let us see. So let us take case one. Okay, case one is, let's say, when the direction of the velocities of two particles A, B are known, and one of the velocity is given and it is not parallel to VB. Okay, so let's see. It is somewhat like this. Let me draw this case. तो यहाँ पे मैं हेडिंग देता हूँ, जस्ट मिनट. Location of ICR. Okay, this you can note it down. It is very important. Let us take case one. Here, where we have when the direction, okay, when the direction of velocities, in the direction of the velocities of two bodies, you can say. Okay. Two bodies or particle also, you can say. Two bodies A and B are known. We simply can say pointers are known, and VA is, let's say, 2 points A and B. So out of this, VA is given and it is not parallel. VA is not parallel to VB. That is velocity of point B. Okay. So let's say for example ऐसा है कुछ, यहाँ पे rigid body है. Okay, this you can say particle because rigid bodies are made up of several particles. Bodies में दो particles है जिसके हमें velocities पता है. Okay, so let's say this is point A. This is point B. Okay. Now let's say this is let's say this is VA. अरे शांत हो जाए. Hello. Hello.
Yes,
So
sir.
am I
sir.
audible? हाँ.
आराम से बोलो सर.
सर थोड़ा जोर से बोलो ना.
Okay.
नहीं नहीं, बहुत जोर से, आराम से.
Let's say this is VA and let me draw the direction of VB. Okay. It is something like this. Okay, ऐसा कुछ भी एक random मैंने assume किया. ठीक है. एक मिनट ना, ये point B को हटा देता हूँ. ठीक है. तो अभी मैं सपोज यहाँ पे assume करता हूँ this is point B. हाँ, तो ऐसा कुछ है let's say. Okay, अभी it is not like that कि always it will be in this situation only. Okay, ये कैसा भी हो सकता है, but केस क्या होगा कि यहाँ पे आपका जो है, हाँ, यहाँ पे क्या होगा कि when the direction of, देखो उसके अंदर हमें कोई भी दो पॉइंट का वेलोसिटीज पता होगा, उसका डायरेक्शन भी पता होगा. ओके, दो पॉइंट का, एंड दे विल नॉट बी पैरेलल टू ईच अदर. तो इसमें देख सकते हो आप, दिस इज पैरेलल नहीं ना, दे आर नॉट पैरेलल. करेक्ट, राइट? हेलो, कैन यू सी दिस? VA is going in this direction, VB is going in this direction. Is it okay? Hello.
Yes, sir.
Yes, sir.
Now now this body, let's say if it is performing a GPM, okay, now I need to find out first the instantaneous center. Okay, so how to get that instantaneous center, that is the question mark. So अभी कोई बता सकता है कैसे करेंगे? See now, यहाँ पे I know, see the direction of velocity. One thing is very clear to you, जो भी मेरा instantaneous center होगा, ठीक है, वो इंस्टेंटेनियस सेंटर कहाँ पे लाए होगा, एक चीज ये हमें पता होगी. ठीक है, कि दैट विल बी ऑलवेज, बिकॉज आई नो v इज इक्वल टू व्हाट, v इज इक्वल टू ओमेगा इनटू r. ओके, एंड अभी मैंने ये वाला केस आपको दिखाया, ठीक है, और ये बोला था कि वेलोसिटी ऐसा होगा अगर ये कैसा है, ऐसा है. ठीक है, आर यू एग्री विद दिस? दैट मींस इसका जो ये सेंटर से इसका जो डायरेक्शन है, दैट इज व्हाट the center of this point is this r. Similarly, ये जो सेंटर है इसका, ये VB के लाइन ऑफ एक्शन पे आ रहा है. दैट मींस यहाँ पे भी ये कहीं पे तो होगा. ओके, ठीक है, दैट मींस ये जो लाइन ऑफ एक्शन है इसका, आई विल जस्ट एक्सटेंड इट. ओके, आई विल जस्ट एक्सटेंड इट. ओके, एंड अगेन व्हाट आई विल डू, I will check whether I am able to get it or not. Yet I am not able to locate the I part, that is ICR part. So what I will consider now, I will what, I will have another line which will go through point B. That will be my second point. Okay. So यहाँ पे मेरे पास दूसरा point भी है. If I will draw the line of action of VB, okay, so this will intersect this line जो मैंने पहले draw किया, and that intersection point will represent my SCR. But one thing you have to note is that whenever you will draw the line of action for this will be always exactly 90 degree ना, correct? यहाँ पे देखो ये होगा, ठीक है? Velocity is always normal to the what axis of rotation, is correct ना? Are you agree with this? तो यहाँ से भी क्या करोगे आप? This you will again you will draw 90 degree line, ठीक है? Exactly perpendicular to VB, and what you are going to get? These two lines are intersecting about this, correct? And this point will represent your. This point will represent your I point. Correct? Hello. How many of
Yes,
you
sir.
are not getting this? किसको नहीं समझ में आया? Hello. समझ में आया? समझ में आया सबको?
Yes, sir.
Now see, this is my IC. I know time is over. I know time is over. Okay, so just give me 2 minutes. I will conclude this. Now see here, this point I. This is a point. This is ICR. Okay, at ICR. Okay, at ICR, each of the particles. Now once ICR is located, what I can find using this ICR, I can find VA as what? Omega into this distance. That is what? If this is a point A, I can just multiply this I से A का जो distance है, this distance, right? This is I A, and omega B will be what? Sorry, V of this point B will be what? This I into B, correct? The distance of point B from this ICR, because I am considering the motion of these particles as a pure rotation about this point I as a pure rotation. So that's why this will be omega into IB, correct? Because at ICR, what I said, na, omega is constant for all the particles, correct? Or rings. So here, if omega is constant for all, then I can use this omega. Correct? अगर ओमेगा का मेरे को प्रॉब्लम में दिया होगा, ओमेगा will be given in the question with its proper direction, whether it is rotating clockwise or anti-clockwise, it will be given in the exam. Are you getting me? So if VA and VB are known, we can
Sir,
determine.
410.
हाँ यस, मैं वही तो बोला ना अभी, तो 2 मिनट सिर्फ लगेगा और ठीक है. This can be VA upon I, this can be VB upon IB, correct? तो अगर VA पता है,
Yes.
VB पता है, तो I can calculate this omega. If I know omega, I can calculate VA and VB. Is it okay? Hello? Any doubt?
Yes, sir.
So here, that's all for today. In the next lecture, we'll see the remaining cases. Okay.
Yes.
This is the case 1. Okay. In the next lecture, we'll see the remaining cases. So let me just take the attendance. Anybody want to ask anything? Hello.
Sir, can you share that note?
हाँ वो तो एंड में करूँगा ना, अभी प्रॉब्लम वगैरह डिस्कस किया नहीं है ना, वो होने के बाद फाइनल जब हो जाएगा तब करूँगा, ठीक है?
लेक्चर वाइज नहीं करोगे?
नहीं, लेक्चर वाइज तो आपको इसमें ये रहेगा ना रिकॉर्डिंग, तो लेक्चर वाइज वो बाद में उसमें इकट्ठे मिल जाएगा ना आपको, ठीक है? For that you can refer the recording. ओके, तो अभी किसी को कुछ पूछना नहीं है ना? Shall I end the meeting?
अटेंडेंस ले लिया सर.
हाँ, sorry.
अटेंडेंस.
हाँ, attendance हो गया. Those who want can leave. Okay, if you have no any queries. किसी को कुछ पूछना है तो
Thank you, sir.